this topic is to show you how to calculate numbers between decimal, binary and hexadecimal. And these are important because your binary number systems helps you to understand what a computer sees as ones and zeros, and we as humans see it as in a decimal format, right? And then you have your hexadecimal numbering system, which calculates also between decimal and hexadecimal systems. And these are how your MAC address works, which we discussed lately during your term, and also your IP version 6 address ranges, which we'll also discuss at the later stage. So these are the two main things that we will discuss, and the objective of this topic, right? So it's your base 2 numbering system, and also your base 10, which is your decimal, and in hexadecimal is your base 16. Those are the three different numbering systems we'll discuss during this topic. Alright, so for introduction, you should see that it is a set of values to present quantities known as numbering systems, right? And numbering systems is called, like I mentioned earlier, it's a base or radix. And I think the most common words that people would use is base 10 or base, let me just make a note for you. So let's do this pin. Right, so you have something where you have a 10, right, and then you have a little 10 at the bottom, right, so that is a base 10, and then you have a 2 and maybe a 16 at the bottom. Just undo that. Apologies for this, just me using this. So let's say you have a 12, right, and then you have a 2, that should be 2, right, so that is a base 2, right, and that's 10, so that represents decimal. And then if you have, let's go 1 on 1, and then you have your 16 there at the bottom, that is base 16. So if you look at the three different numbers that you see in front of you, to highlight, right, so this represents base 16, which is hexadecimal. This represents base 10, which is decimal, and this here represents base 2, which is your binary format. And this is how you would define your different bases based on as we go forward with this introduction to numbering systems. Right, so as I said earlier, you have a decimal numbering systems, which you can see here. It's this one here, the 10, right? That's your decimal numbering system. And then you have your binary numbering system. So your binary numbering systems is your base 2, if you can see here, right? And then you have your hexadecimal numbering systems, and that is your base 16, which you can see there. Now we will explain later how do we get to this conversion stage, but the main important thing for now is for you to understand the difference between these numbering systems and how it actually works, and how the computer works, and how we convert decimal to binary and vice versa. Octal number systems is not important in the scope, as this is base 8, and we are not going to discuss this, and it's not covered in the scope. But there is something called octal numbering systems, which you will learn about that next term in ICF, because then that is where we'll continue with numbering systems on the IT fundamentals part. But for the networking part, these three numbering systems are extremely important, because it allows you to convert a IP address to a normal human readable decimal IP address to binary format, and it also helps you with subnetting, which you will learn at the later stage, right? So that is why these are extremely important. Right, so getting to a decimal numbering system, right? it is basically how you count from 0 to 9, right? And if you look at the example here, 1 2 3 4, right? So it basically looks at base 10, right? So that is what you're looking at. And if you look at this, the 1 represents thousands, the 2 represents hundreds, 3 represents 10 position, 4 represents the units. These are different positions of this number, but you know that the value can be written as that, right? So if you had to convert this and change this, right, you then basically look at it in the sense of you have 1 times 1,000, 2 times 100, 3 times 10, 4 times 1, right? That is how your base 10 works, right? So you can see it's incrementing 1, 10, 100, 1,000. If there was a fourth, if there was another fifth number here, this would be 10,000, and you continue and you go on, right? And if you look at it, you can see then it's 1 times 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, 10 to the power of 0, right? And you start always from right to left if you have to work out your power, numbers of powers. And then if you look at that, you can then conclude and say that this is 1,000 plus 200 plus 30 plus 4 gives you 100 and 234. That is how you would work out to get to that number if you have to do a calculation as this, right? So it's extremely important that you need to look at the things that you highlight here. Is that you need to know that you start from 0 and you walk your way up, incrementing 10 to the power of 0, 10 to the power of 1, depending on the number, decimal number that you see in front of you. So if that number had to be 1, 3, 5, 7, right? Then you would look at that. The 3 would then obviously be 10 to the power of 0, right? So that would be the 3 there, and then 10 to the power of 0. That's always the same. The 2 would then represent the 3 here, which would be 10 to the power of 1. The 1 would then be here, in this place here, which is 10 times 10 to the power of 2. The 5 would then be here instead of the 1, and that would be 5 times 10 to the power of 3. Then you have a 7 here, and a 7 would then be, if we had to draw it here, we would say that it would be, let's just do that for you, color black, right? So if you had to do the 7, right, if you had to do a 7 here, we would then say that would be 7 times, right, 10 power of 4, right? And then you get your answer, and your answer that you will get there would mean that you will get to that amount there. And what would that be? You know the answer if you work it out. You calculate 7 power of 4, 7 times 10 to the power of 4. So 10 to the power of 4 is, you know the answer. You can use your calculator. You should actually know this by now, but it's 10,000. Should it be? Not, then I am wrong. So that should help you to understand how this whole numbering system works, right? So you could then use a calculator, or you can get to a scientific calculator. It doesn't matter, as long as you know that if you had to work out 10 to the power of 4, and you have to put that under let's just go back. I just want to understand what's going on at this step. Let's pause for a moment quick. Alright, so we now worked out that 10 times 10 to the power of 4, so that would be, let's put that there, so that would be 7, and 10 to the power of 4 is what? 1, 0, 0, 0. Right? That's 7 times 10,000 gives you 70,000. Right? And that's why you got to that number. That's how you work out your decimal to binary. Okay, makes sense? Right, I'm going to leave it to you. You can think about it, how we got there, and how does it actually work. And I'm going to continue now with the next slide. Right, so system, bases, and symbols. Right, so decimal, we explained that it is base 10, and your binary is base 2, hexadecimal is base 16. And if you look at the symbols, let's change the color again. Let's go to yellow. You will see that you count from 0 to 9. Binary, you just count in zeros and ones. Very important that you know that. And hexadecimal, you can count from 0 to 9, and then you would start from A, B, C, D, E, and N, Z, F, which is 15 numbers, right? And that is your base 16. Okay, so let me continue and just do the next slide. Right, so your binary number system uses, as I explained, zeros and ones, right? Your base 2 numbering system is what it's called. And then if you can look at example here, this would be 2 to the power of 0, right? So that represents 0 power base 2, right? And the last position of the binary represents power base 2, which means your 2x, where x means the last position, minus 1. That is what you have to remember. Okay, so let's move on to the next slide. So if I had to calculate decimal binary, right? So if your binary number, which is 10101, you can see here, right? And 2 clearly states that it's a binary number, base 2. Now to your conversion and to convert this to decimal, you would then take your binary number, put it in your binary table, which will explain shortly how does this table work, right? Same process what you did with the base 10, and then you add all the numbers together, right? And then you get your decimal conversion of your binary number to get to 21. Now there is a table formula that you use to get to this answer, and we'll explain that later on. We'll just go through the next slides. We'll explain it later on. It's not covered, it's not shown in this slide. Right? See if I can draw this for you, not to waste too much time, because I will shortly end this presentation so we can continue with the next part. Let's just go to that in color. So I will draw a table here in Hawaiian. That should be a table. Okay. So 1, 2, 3, 4, 5, 6, 7. That's 8. So if you look at your binary number, right? You would then be 1, 0, 1, 0, 1. That's what you're looking at. If you look at it binary, right? This will then all be 0, 0, 0, right? And if you look at your base 2, you would then see 2 to the power of 0 is 1. Is it? Correct me if I'm wrong. 2 to the power of 1 is. Alright, gave you time to think. Okay, so 2 to the power of 0, which you see here, this part here, right? Let me just clear that. Don't want me to do that. Raise. Okay. so 2 to the power, okay, so let's just do this table, right? So 2 to the power of 1 is 2, right? So that's a 2, and that would be a 2 to the power of 3 is, because you work from this way forward, right? Power of 3 is, what is to the power of 3? I'm giving you time to think. Wait, we're not supposed to skip it. This first 2 to the power of 2. We will get to 2 to the power of 3. 2 to the power of 2 is 4. 2 to the power of 3 is 8. That should be 8. Let's just undo this. Okay, so that is 8. Decided to make that. And then 2 to the power of 2, right, is, we said 2 to the power of 2 is, what was 2 to the power of 2? So 2 to the power of 3 is 8, but we're missing a number here. Let's just undo. There's something wrong with your calculations. Where's your 4? Right, 2 to the power of 2 is 4, not 8, right? Okay, I hope you guys caught that. I did it on purpose, just to see if you would actually figure out what I'm doing and how I'm getting to the answer. As this is recording, I can't ask you in class, and that's why I'm just trying to test you to see if you know what's happening. Alright, so let's undo that mistake. Okay, so I'm going to continue. So this should be 4. Right, that should be 8. That should be 16. That should be 32. That should be 64. That should be 1, 2, 8. Right, so that is your binary table. Right, so as you can see, excuse the table format, that to get to work out your binary number, as you can see here, convert this binary to decimal, you use your binary table, which you will see here, right? These are all your binary number formats. So that would be 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 6 and 7, right? Now what you do is you look at that numbers there, and you then look at your binary, and wherever you see 1, that gets added as part of calculation. So if you look at the 1 here, it's the 1 that's added there, it's the 4, it's the 16, and you count 16 plus 4 plus the 0 plus 1, because 2 to the power of, yeah, that was also added 0. That should stay 0 if you look at this example here, right? So 0 times 2 to the power of 1 is 0, because you have to add everything to get to that answer, right? So that's how you do your decimal conversion to binary. Okay, it's now been 20 minutes recording. I think let's stop here so that you understand just how binary works. Next we'll do hexadecimal, and then we'll convert that to hexadecimal, and we'll understand that. So for now we'll stop with binary. I hope you guys understand what I did and how I got to the answer. You will get exercises and also the test that will be on Blackboard to assist you with this, and to help you with the test. Right? Thank you.